So the first problem we're going to tackle is how to turn degrees into radians and back. So the way we're going to do this is to understand how to get rid of the degree sign symbol is just like trying to get rid of a number in the numerator. So let me draw an example. So for example, 60 degrees. So you want to get rid of degrees, and so you set over 1 and you multiply it over. Okay, alright, before we do anything, let's cover the fact that pi is pi equals radians. Okay, so we're essentially doing the same thing. We're essentially multiplying this by 1 if we do this, correct? So we're essentially multiplying this by 1 because this is essentially the same deal. But so what we are trying to do is to get rid of the degree symbol. The way we're going to do that is we put the degree symbol in the denominator so it cancels out later on, and we just fill in the numerator with whatever's left, and so we have this sort of thing. And if we can simplify that, we just cross out the degree symbols and we multiply. That is 60 degrees in radians. And now if you find a question that has radians and they're asking you to turn it into degrees, it's fairly self-explanatory. You just do the opposite. So you set a fraction bar, you put whatever you're trying to get rid of in the denominator. So we're trying to get rid of the pi because we're trying to get rid of radians, and we want to turn it into degrees. So whatever you want it to be goes on the numerator. So if you want it to be degrees, you put it on top. Other words, 60 degrees. Okay. So the next thing we're going to be talking about is arc length. So the radius is 6 feet and the angle is 2 radians. So the way I learned this is a whole circle. Let's say okay, so this is our circle. So we know that the radius is 6 feet, and we're trying to find the arc length of this angle. So the way we're going to do that is by setting a ratio. So for example, this is 90 degrees and this is 0, correct? And then the easiest way to make a ratio is, so right now we're going to find the arc length of 90 degrees. So 90 over 360, because we only need 90 degrees out of 360 degrees. We need one part out of a whole. So this would otherwise mean 1/4. And 1/4 of the circumference of the circle is whatever this arc length is. So if we find the radius, or if we find the circumference of the circle, it shouldn't be very difficult to find the arc length of 90 degrees. So let's work out how to do the actual problem now. So we're going to be finding the arc length of 2 radians. So the first thing we're going to do is we're going to set a ratio. So since this is in radians, we know that a full rotation is 2 pi, and so you put 2 radians over 2 pi, or that's just equal to 1 pi. So since that is our ratio right now, all we have to do is find the circumference of the whole thing. So since they give us the radius, we can find it using the formula I believe that's what the formula is. So we plug it in and we get 6 pi and yeah, so we get this formula, but so we still have to multiply it by this number because this is the whole circumference. We're just trying to find the area of this ratio. So by multiplying it by the ratio, you only get the one section that you need. So we're gonna cancel that out, cancel this and that, and so all you have to do is just multiply these two numbers, and you would have 12 for your arc length. Okay, so the way we're gonna tackle the area is a bit different. Okay, so again, we know that the ratio is 1 pi, and we need to find the area. So this time, instead of finding the circumference, we find the area. So we just use pi r squared. So once we plug our numbers in, it becomes it becomes 6 squared. Alright, so all we have to do is again just multiply it by the ratio. Cancel. So the area would be 36. Okay, so we are trying to find all 6 trig values of this particular point. So what we're going to do is, obviously, these are x and y, and we know that x equals cosine and y equals sine. So now that we know that they're all equal, we can basically draw out our 6 trig values. So the first thing we probably want to do is just put our values in. There you go. So if that's what the value looks like, well then we can also do tangent. For tangent, we know that tangent theta equals y over x. Otherwise, sine over cosine. So we can just solve for that by putting over when you divide by a fraction, it just means that you're multiplying by the reciprocal. So I'm just gonna scratch this out. I'm gonna multiply by the reciprocal. So square 3 and 2. So the 2's cancel out and you're left with 1 square root of 3. So that's your that is your tangent value, but we still need to rationalize it by multiplying it by essentially 1. But a square is 3 over square root of 3. So that would make it square root of 3 over 3. And so the next step is just to find the opposite values, if that makes sense. So cosecant is basically just the reciprocal of whatever this is. So cosecant should be 2 because it's just 1/2 flipped over, and secant is that but flipped over. So that would be 2 which is 3. But we have to rationalize, so we multiply it again by that, and that's going to equal 2 square roots of 3 over 2 over 3. Then for cotangent, it's kind of really easy. So cotangent theta is equal to, so remember when we rationalized this, right? Well, scratch this part out now and just take this part and flip it over, and so now we're left with square roots of 3. Now square roots of 3. Okay, I'm sorry for the messy handwriting, but I was raised with it. So find exact value of cosine 7 pi. Okay, this is no different than what we've done before, except this just goes over 2 pi. So again, drawing my unit circle. Ugh. Okay, so the unit circle. So we know that one rotation is 2 pi. And so if we just keep going, that would be 4 pi. And so on and so forth until you reach a value under 2 pi. So I'm going to be subtracting 2 pi over and over again until I get to something under 2 pi. So we get 5 pi, we got 3 pi, we go to 1 pi, which is just pi. Okay, so this value is essentially just the same as saying cosine pi. And we know that pi is just 180. So what is the cosine value of 180 degrees? So if we go to 180 or pi, we can see that it's the point is found in -1, 0. So the cosine value is -1. So the answer is -1. So moving on to, so find the exact value of 4 other trig values. Okay, so with this we know that sine theta is equal to 4 over 5, and we know the formula for that. That's, I believe it's y over r. So if we find the Pythagorean theorem thing, we find that x squared plus y squared equals r squared. So we can plug them in to find other values. So tangent is equal to, so tangent is, we know, tangent is equal to y over x. So since tangent equals y over x, we could use just these values. So if sine is y, we can plug it in for that. So we only actually use this value instead of this whole thing. So we use 4 over cosine is 3, so we put 3 down. And we're done for the tangent. We just need the cosecant value. So it's essentially just, again, flipped over. So you can just reuse them. But be careful, because you can easily mess this up by like forgetting to simplify or something. Because sometimes when you do something and it ends up being simplifiable, if that makes sense. Like for tangent, if you put them together, you can't just leave them like that, because if you can simplify them, make sure to simplify. This is what I'm saying. So yeah.